Hello students, welcome back to another algebra video. Pause the video, try these problems in your notes. They are from the last video, and then unpause the video to do them with me. Let's jump right into it. So, I noticed that we have an x on this side of the equation and an x on this side of the equation. So, we need to decide which side we want our variables on, which side we want our numbers on. Now, because this side only has a variable on it, I think it would be easiest to get our x's over here and our numbers over here. But remember that some of us don't like negatives, so if we subtracted 3x, we would get minus 5x, and some of us really hate it when that happens. Now, do I care? No. Does your teacher care which way you do it? Maybe. Check with them. But I want to show you what happens. What if we want to keep our x's positive? So we want to move the negative 2x over here. I want to show you what happens when we do that. Say you want to move the 2x over here. So you're like, okay, opposite of negative 2x is positive 2x. Great. I'm going to add 2x to both sides of the equation. Now I have 5x plus 10. What should go on this side of the equation? Should we just lose the equal sign and, 5x plus 10, and then divide 5 on both sides? No. No, 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 no. You cannot do that. You cannot do that. What starts with an equal sign must end with an equal sign. You cannot get rid of the equal sign, because now you don't have an equation anymore, you have an expression. And if you manipulate an expression, if you divide it by 5, you have completely changed the expression. But if we have an equation with an equal sign and we divide from both sides, that's okay, because we will have an equivalent equation. Expressions don't have equal signs, so you can't keep them equivalent. So do not lose your equal sign. If you're like, she talked, but I did not understand what she was saying, that's okay. What you need to know is do not lose your equal sign. Do not lose your equal sign. That is huge. Write that down. Write that down. Even if your teacher doesn't make you take notes, write that down. Put some hearts and stars by it. That is so important. So incredibly important. Okay, so we know not to lose our equal sign, but what does happen over here? What is on this side of the equal sign? And remember that you cannot divide both sides by 5, so remember, we're just erasing that because you can't do that. So what is on this side of the equal sign? Negative 2x plus 2x. That's like if I have negative 3 plus 3, what is that equal to? Well, let's see. Negative 3 plus 3, that's the same thing as 3 minus 3. And 3 minus 3, that's 0. So negative 3 plus 3 is 0. So if I have negative 2x plus 2x, that's 0. That is 0. And if this is confusing to you and you're like, Miss Dodge, you have lost me, I don't know what you're doing, that's okay. Just put your x's on this side. You can do that too. I just wanted to show you that if you chose to get rid of this, you have 0 equals 5x plus 10. The equal sign doesn't just go away. All right, so now I have 0 equals 5x plus 10. And you would do this just like you would any other equation. I'm going to subtract 10 from both sides to get rid of the 10 on this side. And now we have negative 10 equals 5x. You want the x by itself, so we divide by 5 on both sides. And x equals, let's see, negative 10 divided by 5 is negative 2. And that's a little hard to read over there, so let's write it over here. X equals negative 2. All right, remember, it says to check your solution, So you definitely want to check your solution, but we're going to skip it for the sake of time because you know how to do that. All right, let's move on to our equation over yonder. Let's get a different color. I like purple. All right, so here, remember that we do, oh, you can't see that very well. We'll stick with the black. Remember, distribution first. Always distribute first. So we are going to do 1/2 times 6h. 1/2 of 6 is 3. H, don't forget the H. I'm going to draw our line right here. And then 1/2 times -4, that is negative, let's see, 1/2 of 4 is 2. Equals -5h plus 1. There's no simplifying we can do over there. We can't put these together. Remember, one is an apple and one is an orange. So we cannot put them together. Okay. So now, which side do we want? Do we want our h's over here and our numbers over here? You decide. Well, you already did, because you tried these problems without me. But I am going to put my h's over here and my numbers over here. Because in order to move this 5h, I need to add 5h to both sides. And that's going to keep the h's positive. When I come over here, 3h plus 5h is 8h. So I'm keeping the h's positive. And I like positive h's. All right, everything else comes down. -2, these canceled out, equals 1. Wonderful. And in order to get rid of the 2 over here, or the -2, I need to add 2 to both sides. So now we have 8h equals 3. And now, in order to get rid of the 8h, I need to divide by 8 on both sides. We're getting real teeny down there. All right, and now h equals 3/8. Now I know what some of you are thinking, or maybe you thought while you were doing this problem, fractions? I did something wrong! Not necessarily. Maybe your teacher creates their problems so that everything comes out as a nice even number. That doesn't always happen in the real world. We don't always have nice even numbers in the real world. So, it could be possible that your answer is a fraction. Remember, plug it in to check and make sure that you had the right thing. Okay. So, day 2 of section 1.3, still solving equations with variables on both sides. But today, our learning target is you know what an identity is. And our success criteria is that you can solve linear equations with special solutions. Ooh, special. Yeah, so the problems today are going to look a little different. They're going to look the same, but their answers will look a little different than normal. Usually we have x equals 2 or x equals some number, and that is our answer. Today, things look a little bit different than that. So, let's dig right into it and see what an identity is and what our special solutions look like. All right, first, some vocab. So I would recommend that you pause the video and write this down. If you're my student, you probably are pausing the video and writing this down. An identity. What is an identity? Well, an identity is an equation that is true for all values of the variable. So, and in different areas of math, an identity means different things, so don't get confused. But an identity is an equation. It's a special equation. It's an equation that no matter what the variable is, the equation is true. I can put any number into this equation and it'll be true. If you don't believe me, let's try it. X equals, what do you want? Let's do 1. Let's do 1 for now. If I put that into this equation, I get 2 times 1 plus 1 equals 2 times 1 plus 2. So this is 2 times 2 equals 2 plus 2, and that is 4 equals 4. Boom. X equals 1 works. And I know what you're thinking. Okay, all right, lucky. You got lucky. Sure, x equals 1, but x can't equal multiple things. Yes, it can. It can when you have an identity. So let's try it again. Let's make x 5 this time. So now I have 2 times 5 plus 1 equals 2 times 5 plus 2. So now I have 2 times 6 equals 10 plus 2. 2 times 6 is 12, and 10 plus 2 is 12. What? Oh my goodness, so x equals 5 is also true. Yes, this is what an identity is. It means that no matter what x is, this equation will be true. X can be anything. It can be 500, it can be 5 million, it can be 2 million, it can be whatever you want it to be. So these two equations, both of these equations, are examples of an identity. So if you plug anything for x into this equation, it will also work. And of course, the Spanish should you need or want it. Okay, so now that you know what an identity is, we are going to have a little more context about them. So, special, remember that was in our success criteria, special solutions of linear equations. So, equations do not always have just one solution. An equation that is true for all values of the variable is an identity and has infinitely many solutions. Infinitely many, so the word infinite means like so many you can't count. So when it says infinitely many solutions, it means literally it is impossible to count the number of solutions. So up here, we mean x equals 5, x equals 2, x equals 1.2, x equals 1.23, x equals everything. X equals every single number that exists. There's no way that you can count all the numbers that exist. 1/2, 4/5, 8/5. How do you count them all? You can't. So, if an equation is an identity, it has infinitely many solutions. So write this down. I would definitely suggest that you write this down. Okay. And an equation that is not true for any value of the variable has no solution. So sometimes, no matter what you say, x equals 5, x equals 3.3, x equals whatever, sometimes an equation just doesn't work. It doesn't have any solutions. And that's okay. Then we just say there are no solutions. Okay, so now you know, okay, great, Mrs. Dodge. If I have an identity, infinitely many solutions, sometimes there's no solutions, cool. What might an equation that has an or that is an identity or that has no solution, what might that look like? I'm so glad you asked. Let's talk about it. Let's see some examples. So, solve each equation. Cool, let's do the one on the left first. So, first, always do my distribution first. So I have 3 times 5x. This is 15x. Draw my line there. And now 3 times 2, that is 6. Okay, and then I have 15x on this side. All right, so remember, I have an apple over here, I have an apple over here, I have an apple on each side of the equation. So I'm going to choose to put all of the x's over here and all the numbers over here, because this side already, it just has x's. It doesn't have any numbers. It doesn't have any oranges on it. Okay, so I am going to subtract 15x from both sides. That goes away, and I get 6 equals 15 minus 15. Wait a minute. 15 minus 15, that's 0. Wait a minute. 6 equals 0? No. No, 6 does not equal 0. So this right here, this is where you have no solutions. Remember, we just said that an equation that is not true for any value has no solution. This is one of those equations. It has no solutions. And the way we know that is 6 does not equal 0. This makes no sense. So there can be no solutions. So anytime you get something that is not true, you get 3 equals 0, you get 5 equals 4, you get something that like, no, 5 is not equal to 4, 3 is not equal to 0, no solutions. And the way that I remember that is I say 6 equals 0? No! No solutions. No solution. Okay, you get it. Yeah. All right, let's move on to the next question. All right, remember distribution first. I'm going to do my distribution rainbows first. So there's my line. And negative 2 times 4y is negative 8y. Negative 2 times positive 1 is negative 2. And this equals negative 8y minus 2. Now pause. I mean, don't pause the video, but pause us doing the equation, or solving the equation. Because look at this. This is the exact same thing. We are saying negative 8 minus 2 equals negative 8, or excuse me, negative 8y minus 2 equals negative 8y minus 2. That's like saying 3 equals 3. That's always true. 3 is always equal to 3. Negative 8y minus 2 is always equal to negative 8y minus 2. So this is going to have infinitely many solutions because it's always true. We can go even further, though. We can go even further. So say you don't notice that right away. Say you don't see that it's negative 8y minus 2 and negative 8y minus 2. That's okay. Let's put all of our variables on one side and all of our numbers on the other side. So I'm going to put y's over here, and I'm going to put numbers over here. So I'm going to add 8y to move it over there. Add 8y to move it over here. So that goes away right here. And I have, oh wait, negative 8y plus 8y. That also goes away. And I get negative 2 equals negative 2. There you go. Does negative 2 equal negative 2? Yes. Yes, it does. So there are infinitely many solutions. Infinitely many solutions. So over here, we had no solutions, and here we have infinitely many solutions. So usually, you get x equals 2, y equals 3. You get something like that, usually. But sometimes the variable disappears. When you're working on the equation, the variable cancels out in some way. And when the variable disappears, you either get something that is false, 6 equals 0, false, not true, and then you have no solution. And sometimes, when the variable disappears, you get something that is true, and then you have infinitely many solutions. So, this will only happen if the variable disappears. If the variable doesn't disappear, you get x equals 5, x equals blank, whatever number. If that x disappears and you get 0 equals 5 or 5 equals 5, that is when these special cases come into play, these special solutions. Okay, alrighty, let's see if we were correct. 6 equals 0. The statement 6 equals 0 is never true, so the equation has no solution. And part B, the statement -2 is always true, so the equation is an identity and has infinitely many solutions. Okay, wonderful, wonderful, wonderful. All right, so I know we saw this in the last video, but we're seeing it again because we're adding on a little new tidbit of information. To check an identity, when you check your solution, because remember, step 5 is always check our solution. To check an identity, you can choose several different values of the variable. That's what we did way back in the beginning when we were like, okay, let's plug in x equals 1. Now let's plug in x equals 5. You can plug in as many different variables as you'd like, 1, 5, 2 million, whatever you want, and it should always work. That's how you can check an identity. Okay, actually, you know what, let's keep that. So the steps are just like usual. First, the distributive property. If there are parentheses, do the distributive property. Next, simplify the expression. Combine your apples and oranges, combine like terms. Then, third step, get your x's on one side of the equation and your numbers on the other side of the equation. Get x by itself, and check your solution. If you want to pause the video and write down these steps, do it. I remember in college, I'd be writing down steps for how to solve a Bernoulli differential equation. I would write down the steps and use those to help me with my homework and then memorize them for the test. That's not the best way to learn long term. Like now, I have totally forgotten the steps to solve Bernoulli differential equation. So if you want to learn long term, don't just memorize stuff. But if it helps you for now, do it. Do it. Not all of us are going to go on to have careers in math. Okay, questions. Do you have questions? If you do, be sure to talk to your teacher, phone a friend, like literally text or call a friend. You can re-watch this video. You can find Khan Academy videos. I'm sure if you Google it, somebody has a video somewhere. Maybe they explain it differently than me. But yeah, ask me, ask your teacher, ask a friend. Yeah, there's the textbook online. Yeah. Okay. Practice problems. So again, these might not be the ones that your teacher assigns, but you can use these to practice if you want to practice getting better at solving systems of equations, not systems, excuse me, solving equations, solving linear equations with special solutions. Here are some problems that can help you practice. All right, and as usual, let's end with a launch. It's okay. It's okay. And it is okay to make mistakes, to have bad days, to be less than perfect, to do what's best for you, and to be yourself. Every single one of these things is okay. It's okay to make mistakes. No one is perfect. You're gonna make mistakes, and that's okay. It's okay to have bad days. We have bad days, and we say rude things, and we do things before we think about them. And we're sad sometimes. We just have bad days. That's okay. It happens to everybody. It is okay to be less than perfect. Spoiler alert, no one's perfect. So we are all less than perfect, and that's okay. It's part of being a human. It is okay to do what's best for you. You might feel guilty, like maybe you have to cut a friend out of your life. Maybe that friend like isn't good for you and you have to like say, sorry, I don't want to be your friend anymore. If that's what's best for you, it's okay. You're not like a jerk about it. You're not like, hey, you suck, I don't want to be friends anymore. Like, no, you don't do it like that. But if you kindly say like, I can't be your friend anymore, that's okay. It is okay to do what's best for you. And finally, It's okay to be yourself. I remember being in high school. I remember the insecurities. I remember thinking no one liked me. I was too loud. I was too obnoxious. I was too skinny. I was too fat. I didn't wear makeup. I was too ugly. Whatever. We always think these things about ourselves. But it is okay to be yourself. Unapologetically yourself. Whether you wear makeup, whether you don't. Whether you're blonde, whether you're brunette. It doesn't matter. It's okay to be yourself. You are beautiful the way you are. You are handsome the way you are. And you are wonderful the way you are. It is okay to be yourself. And I really hope that you do embrace yourself and be yourself. That is my launch for you. Take it with you as you go throughout the rest of your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.